Now, aluminum oxidizes readily. Crystallographically, there are 16 different compositions of aluminum oxide that can exist. They can vary in density or specific gravity from about 2.36, which is pretty close to that for molten aluminum, to up to 4. And clearly, oxides that are heavier should sink to the bottom of the furnace, therefore contributing to a sludge or perhaps corundum formation, such as shown here. Lighter oxides will tend to float to the top of the surface, forming dross or inclusions, and those have their own special impacts on the melting and handling process. Many oxides can exist because of surface tension effects at a bulk density that's very similar to that of the molten aluminum itself. Therefore, they'll be in suspension, and the only way to get rid of them is through a forced flotation, such as with degassing, or filtration. We'll cover that when we talk about metal treatment next week. So oxides, of course, are going to exist in all materials that you're putting into the furnace because aluminum will always have an oxide skin on it. But dirty furnace tools, flux residues, and so forth also contribute to oxides. And this is planet Earth, so we do melt in an oxidizing atmosphere. And when we make transfers, we are both creating dross as well as potentially entraining dross. And as we wear our furnace vessels or our handling vessels, all of which certainly are for aluminum lined with a oxide refractory, once we do any wear or cleaning on those, we will be creating debris and again the potential for oxides to be entrained in the molten aluminum. Now, oxidation increases exponentially with temperature, as shown here, as you see in this chart, and therefore it's imperative to maintain as low a temperature as is practical in the melting operation, and clearly again to make sure that one is utilizing temperature measurement capability that is accurate. If you're not accurate, the melt temperature that the melt is actually experiencing may be higher than what is actually being monitored. As this dross layer builds up, it retards heat transfer, reduces the melting rate, and increases the amount of energy necessary. Therefore, it's going to reduce the melting efficiency.
To purchase access to this course, visit the NADCA Marketplace at www.diecasting.org/store. Purchasing a course through the online education system grants you 1 year of access to the recording, presentation, support material, and test when applicable. NADCA video news and information is brought to you by the following sponsors.